This is your NEET physics paper dated 17th July. So in this, we'll go for first question. That what is the first question? The temperature on Celsius scale is 25 degrees Celsius. That is TC, correct? What is the corresponding temperature on Fahrenheit scale? TF. So we know TC is equal to 180 by 100, that is 9 by 5. So 9 by 5 TC is equal to TF minus 32. This we know. They're asking TF, TC they have given. So TC is 25. 5 ones are 5, 5 will get 45, 45 plus 32. 45 plus 32 is 77. Maximum density of H2O is at temperature. It is at 4 degrees Celsius. So they are asking that in degree Fahrenheit. So again same formula if we use 4 will get here 9 4s are 9 4s are 36. 36 by 5 will get 7.5 plus 32. 39.5. 39 point. Sorry. 7.2. 39.2. Yeah. Then the temperature of the body on Kelvin scale is found to be X Kelvin. And it is measured by Fahrenheit thermometer. It is found to be X degree Fahrenheit when the value of X is. So both are X. So now again same formula you can use. 9 by 5. 9 by 5 TC. But here how much is TC? Temperature in Kelvin is X. So in degree Celsius it will be X minus 273. Correct na? Is equal to TF is also X minus 32. Basically both are same readings in degree Fahrenheit and in Kelvin. Same reading it is. Now you find X value, that's all. So how do you find 9X minus 273 into 9 is equal to 5X minus 32 into 5. So this will go this side 4X, 9X minus 5X. This will go this side. 273 into 9 they have given. I will take this as 2730. I will take it as 10. Then this will be minus 32 into 5. 0, 1, 160 it will be. 0, 13 means 7, 6, 1, 5, 2. So X will be by 4. 1 is 5, 5 is 20, 4, 5 is 20. No, 4, 6 is 24. 1 here 4. 642 point something you will get. So here I have taken approximation. I have taken this as 10. So my answer will be less than this. That is close to this. Then go for next question. A solid ball of metal has a concentric spherical cavity within it. Okay. So it is like this. Here is a cavity and this is a solid ball. If the ball is heated, the volume of the cavity will. Okay. So if the ball is heated, then it will expand. So cavity, if you consider this to be made up of many thin hollow spheres or thin shells, then this layer will also expand. So cavity will increase its size. Volume of the cavity will increase. Right. If on heating liquid through 80 degrees Celsius, the mass expelled is this much, the of mass still remaining. The coefficient of apparent expansion of liquid is okay. Here if you see apparent volume expansion, this was in one more video or last chapter. Sorry, not last uh, paper. Apparent expansion of liquid I had explained actually. So, So here if you see uh, how much air is filled, that is apparent expansion of liquid. It appears that liquid has that much liquid has expanded. But actually, not only that much is the expansion. Expansion is the mass expelled. Real expansion is mass expelled plus expansion of the vessel also. Because expansion of the vessel, how much it is, suppose this is a vessel and this is water. And this is the water. Okay? This is the water. So when you heat, water has actually expanded more actually. Uh, because the beaker has also expanded, right? So water has expanded this much plus how much has spilled out, correct? But it appears to us that only this much is the expanded part because we fail to see the expansion of the container. This is apparent expansion, correct? So, and we had also discussed that real uh, uh, gamma real will be equal to gamma apparent plus gamma vessel, correct? Hmm. Basically, delta V real is equal to delta V apparent plus delta V volume vessel by V delta T you do everywhere. You get this. So now mm, they are asking coefficient of apparent expansion. So, coefficient of apparent expansion is equal to delta V apparent divided by V delta T. Uh, Now they have given delta M actually. If you consider total mass to be, they have given 1/100th of mass still remaining. So mass still remaining if you take as 1, then 1/100th of that is 0.01. So 0, if 1 kg is inside, 0.01 kg has spilled out. So total mass was 1.01 kg. So density is equal to mass by volume. Mass is equal to density into volume. So into density we will do. With this much temperature, we will consider density to be almost constant. Then, as for liquids and solids, there is no much volume change actually. It's so less temperature change. So it will be delta M by M delta T. So if if M mass is there here, 0.0 M mass will be here. And initial mass, total mass was M plus this. That is 1.01 M. So this will be 1.01 M initial mass and change in mass or delta V will be this much is the change in mass. Uh, this will be 0.01 M and delta T is 80. So this is approximately 1 mm cancel. This is approximately 0.01 by 80. Right. If you see what will get 10 power minus 2, 10 power minus 3, 1 by 8. This is 0.1 202 5, right? So if you do this 1.25 into 10 power minus 4. Right? That is option A. Right? We'll go ahead. At some temperature T, a bronze pin is little large to fit into a hole drilled in a steel box. The change in temperature required for an exact fit is minimum. Okay, you should be knowing actually this. If you don't have any idea about that, then it will be a little problematic. That is, steel's coefficient of expansion is more, very high compared to bronze. So if you this is large, so you have to expand it. So if the block is heated, then it will expand very easily to a higher size very quickly. So this is the answer. You should be knowing that its coefficient of expansion is more than bronze coefficient of expansion, right? Um, and we will go for 97. The length of a cylinder on heating increases by 2%. Area of its base will increase by cylinder. So actually this is the alpha only, है ना? Uh, Basically, it's alpha delta T. Delta L by L is equal to alpha delta T. So this area they are asking. So this gives you the measure of one dimension, है ना? Alpha. So area is pi r square. So radius is your again one dimension, one dimensional quantity. So delta A by A will be 2 delta R by R. 2 delta R by R is alpha delta T, which is again delta L by L only almost. So 2 into that is 4. 2 into 2%. Or uh, 4% is the answer. Then a pendulum clock keeps correct time at 0 degrees Celsius. Its mean coefficient of linear expansion is alpha per degree Celsius. Then the laws in seconds per day by the clock if the temperature rises by T degrees Celsius. Okay, and this concept I have not taught in class, I think, but I'll just tell you now how to do. Um, See what you can write. See, we know T is equal to 2 pi root of L by J for a pendulum. And pendulum is how, in pendulum, if you see the clock pendulum, like this. So suppose pendulum is at one extreme, and this is one extreme. Okay. So when the pendulum goes from here to here, that will be 1 second. Then again here to here, again 1 second. So like this it will be. So one time period will be 2 seconds. Okay. So now its length changes, then time period changes, right? So T dash is equal to 2 pi root of L dash by G. Suppose length changed because of change in temperature. Then what will get? Time period will change. Means suppose means initially in 1 second it was going from here to here. Now it will take more time to go from here to here. Correct? It will take maybe 1.3 seconds. So zero point 0.3 seconds. Okay. One thing is, see, when it goes from here to here, this hand, clock's second hand will go 1 second. Only when it goes from here to here. So when T dash is suppose 1.3 seconds, so it will go from here to here in 1.3 seconds. But seconds hand will go from 0 to 1. Means it will show 1 second. Actually, it is showing 1 second after 1.3 seconds actually. Understood. So our clock will run slowly. So this is going slowly. Okay. So now you see. We know L dash is equal to L into 1 plus alpha delta t, correct? Alpha is equal to delta L by L delta t, and delta L is L dash minus L. So L dash becomes L into 1 plus alpha delta t by G. This is T dash. So now if you see, T dash is equal to 2 pi root of L by G, that is T, into root of 1 plus alpha delta t, correct? So T dash by T is equal to, this is whole power 1 by 2. In binomial expansion, if you apply 1 plus half alpha delta t, 1 plus x whole power n, this is binomial expansion, 1 plus x whole power n is equal to 1 plus nx, plus some square terms, cube terms will come. But when x is very, very less than 1, you can neglect all this to 0. And alpha delta t will be very, very less than 1 only in general, correct? Alpha will be 10 power minus 5, something like that. So we can use 1 plus nx. This is a binomial uh, ex, uh, expansion. So what will get now? T dash minus T dash by T minus 1. This one you take this side is equal to half alpha delta T. You'll get T dash minus T divided by T is equal to half alpha delta T. That is T dash minus T is delta T. That is change in time period by initial time period is equal to half alpha delta T. So this is the important formula. So half alpha delta T is change in time period. Suppose you put this capital T as 1 second. So for 1 second, now how much will be delta T? This much. That means this much extra time it will take to complete one extreme to another extreme to come this much. Suppose you put T as 1, capital T as 1, then delta T is suppose 0.3. It means T dash is 1.3, correct? T dash minus T is 1.3. It means T dash is 1.3. It means it has increased by 0.3 seconds. It means to go from here to here, it was taking 1 second. Now it will take 1.3 seconds. So, but when it goes from here to here, then only it goes from here to here. Means seconds hand is suppose at 2. It will go from 2 to 3 only when it goes from here to here. So we feel when it goes from 2 to 3, 1 second has passed, but actually more than 1 second has passed. So uh, this clock is losing time, right? It's losing time because suppose it is evening 5 o'clock, but what it will show? It will show some 3 o'clock or 4 o'clock because actually it was 5 o'clock. It is 5 o'clock now, but uh, because it has went very slowly, this has also the seconds hand is also had also come very slowly. So it has not covered everything for 5 to show it as 5 o'clock. So it will show 3 o'clock. So it has lost the time, correct? And other wise or contrast to this is when when you reduce the temperature, its length will reduce, and when its length will reduce, uh, basically when delta t is negative, delta t will be okay. So this delta t is temperature change. Okay, I should have written. I think temperature is 20. This delta t is temperature change. This is time period change. I will write it as dark. Yeah. So if temperature reduces, then delta this will be negative. Then change in time period will also be negative. It means time period has reduced. It means in less than 1 second only it will come from here to here. So suppose 1 second was there, now it will come in 0.8 second only. So when it comes from here to here, it will go second hand will go from 2 to 3 only again. So it appears as if 1 second has happened, but actually 1 second has not happened. It is 0.8 second as 0.8 second only. But so here if you see, it is gaining time, right? When suppose now 3 o'clock is there, but it will show it as 4 o'clock or 5 o'clock because it has moved very fast. So it gains time. So this is a concept. And one more thing to notice, they're asking. So now here, uh, so here rises temperature rises, so it loses time. So they're asking how much is the loss in time, loss in seconds per day. So per day loss they are asking. Yeah. So for 1 second it loses this much time. For 1 second it loses this much time. Correct. Basically, if you put capital T as one, you will get means for 1 second you will get how much extra time it takes. Suppose 0.3 seconds extra. Suppose 1 second, but T dash is 1.3 seconds. It means 0.3 seconds it loses, right? 0.3 seconds it loses. Right? Means when it comes from here to here, it shows clock will show that 1 second has happened, but actually 1.3 second has happened. So it is losing 1.3 second. It is losing 0.3 seconds. The clock, right? It is not counting the 0.3 seconds. So it is losing 0.3 seconds. So when it is 5 o'clock, it will show some 4 o'clock, suppose. So so in 1 second, it is losing 0.3 seconds. Suppose now 1 minute has happened. So 1 minute means 60 seconds. So 1 second, in 1 second, 0.3 it has lost again here. 2 seconds it should have, uh, it will show 2 seconds there, but actually how much time has passed? 2.6 seconds, correct? And here it will show 3 seconds, but actually how much has passed? 1.3 plus 1.3 plus 1.3, that is 3.9 has passed. So 9 seconds extra. So like that in 3 seconds, how much is the loss? 0.9 seconds, correct? Like that they are asking for 1 day, how much is the loss? So you have to see how many seconds are there in one day. So for 1 second, it will lose half alpha delta t, half alpha delta t for 1 second. But uh, for 1 day, how much it will lose? So basically, you have to put that time here. Here it will be, and delta t will be your loss or gain. This will be loss or gain in time, and this is the time given time period. So our answer will be half alpha delta t into. So in 1 day, how many seconds are there? Right? So in 1 day, how many seconds are there? 24 hours, 60 minutes, 60 seconds. So this will be 36,864,000. It will be. So it will be option B. Yeah. Then we'll go for 28 is over. 99 is nothing. It is Chirag sir's particle. The particle. Hmm. So, okay. Okay. From here I have to start. 117. So if you see 117 problem, two temperature scales A and B are related by A minus 42 and okay at which time both will have same reading. A equal to B. Both should have same reading, so A equal to B. Suppose okay, A minus 42 by here also A minus 72 by this is 110 and 210. So ones are twos are. There will be two here and one here. So 2A minus 4 cross multiply. 2A minus 42 into 2 is 4 and 8 is equal to A minus 72. So A take you this side. And this 84 will come this side. 84 minus 72 is 2 and 12. degree Celsius with that. On centigrade scale, the temperature of the body increases by 30. Increasing temperature of Fahrenheit. So delta Tc is this. They're asking delta Tf. So we know relationship Tf minus 32 is equal to 9 by 5 Tc. Right. Now you take it as Tf2, Tc2, Tf1, Tc2, Tc1. Then subtract both of them. What will you get? Tf2 minus Tf1, that is delta Tf. 32 will cancel. Is equal to 9 by 5 into Tc2 minus Tc1. So delta Tc will get 9 by 5 will be common. So delta Tf is 9 by 5 of delta Tc. That is 9 by 5 of 30. 1 the 6 the 9 6 the 54. Then the temperature of a thin uniform circular disc of 1 meter diameter is increased by 10 degrees Celsius. The percentage increase in moment of inertia. Okay, moment of inertia is not talked to actually, but moment of inertia I is equal to mr square of this type. It will be mr square into some constant, suppose. So basically, it will be proportional to radius square, that is diameter square. Okay. So how much it will be? So percentage increase in moment of inertia there is. So it will be 2 into delta r by r, and the delta r by r is alpha delta t. So it is a linear dimension, correct? So it will be 2 into alpha is 11 into 10 power minus 6. Delta t is 10, and it is percentage increase, so into 100. Then 213 10 power minus 3. We have 22 here. That will be 0.022. Then 120th problem. A clock which keeps correct time at 20 degrees Celsius is subjected to 40 degrees Celsius. Okay, same problem. Again, similar problem. Clock problem. If coefficient of linear expansion of the pendulum is, how much will it gain or lose? So will it gain or lose? Temperature is increasing, then means delta T is positive basically, or length will increase, time period will increase actually. So it will move slowly now, right? Like this, it will go slowly. So it was supposed to go from here to here in 1 second. Okay, I will draw it. So it's pendulum. It was supposed to go from here to here in 1 second. Now it will go in more than 1 second. So it will lose time. Correct. So how much will it lose? Half alpha delta t. And per day they are asking. Basically it is this will be for 1 second. Huh? This is delta t for 1 second. For these many per day means 86,400 seconds. So you can keep it here this side. It will become into t. Okay, if you indicate it by t dash and into t time. So half into alpha is 12 into 10 power minus 6 into delta t is 40 minus 20 degrees Celsius. So 20 into 8,600, 86,400. So what will you get? 1 za 10 za 10 power minus 6, 10 power 3. 10 power minus 3 I will keep here. Then 864 is there and 12 is there. Okay. So now what to do? You see, if I take it as 800, and if I take it as 10, 810, 8,000, 10 power minus 3, 8 I will get. I have reduced, that's why I got 8. If I just 10. Or you can solve also. 860 we can take at least. 860 into 12, if you do, what will you get? 10 you keep. 12 12 and 2 8 the 16 7 and 86 2 13 10. So we'll get 10.3 है ना. Then I think now Chirag's first part is there. Yeah, no, Chirag's first part is there. So any doubts you can ask in the class.